good afternoon. I think maybe still a lot of people enjoying the lunch. But anyway, we are going to start. I'm Liang from Huawei, in charge of cloud network planning. Today, it's my big pleasure to share with all of you regarding Huawei's journey for the cloud transformation and also how we are going to evolve our solution to 5G. Okay, here is our journey. I think Huawei is the true believer of the cloud transformation. And also, we are the technical pioneer for this kind of cloud transformation in past years. And for myself, I was in charge of cloud EPC planning, and I planned the first release of Huawei Cloud EPC. So if you look at our journey here, starting from 2013, we came up with our prototype for our cloud EPC. And after that, for the whole Huawei company, we launched Softcom solution. And also, from day one, I still remember very clearly, shall we use today, a lot of people talk about cloud native, stateless design, so on and so forth. But actually, from Huawei perspective, even from day one, we had a lot of debate. Shall we redesign our software architecture or not? We had a lot of debate, and finally, we decided to redesign our architecture to make it stateless. So that's the reason why, from day one, we started to market virtualization is not equal to cloudification. So based on that, from day one, we redesigned our cloud EPC. We use stateless design, like this one. In 2015, it's already commercialized. We support NV redundancy, which can tolerate multi-point failure. And also, based on this architecture, it's very easy for us to support the COPS and also A/B test, even for our cloud EPC era. So based on this, we have won more than 600 cloud NFV contracts, which is, I would say, the majority of the contracts we got. And also, we are serving more than 1 billion subscribers around the world. And also, if we look at the 5G, we believe that automation would be more important. That's the reason why, from last year, from Huawei perspective, we launched another, we call it Softcom AI. And also this morning, my colleague introduced our AI solution for the automation. And currently, we believe that for the cloud transformation, the cloud native is a foundation for 5G cloud network. And also, software and hardware decoupling is almost finished. But still, the ecosystem is not so mature, like multi-vendor integration, specification, and also open source. There are a lot of open source community. So based on this, we believe that still, the automation capability is still the drawback for today's cloud transformation. If we look at 5G evolution, we believe we are facing more and more challenge and more requirements from 5G cloud network. The first one, we believe that for 5G, the first challenge is user plane performance. Even today, for cloud EPC, for BNG, we understand that for the user plane performance, it's a big headache. And for 5G, it would be 10 times throughput than before. So how we are going to address the performance issue, how we are going to improve the hardware efficiency, that's the first challenge. The second one is for the COPS and also for mobile edge computing or multi-edge computing. We believe that for low latency requirements, the edge size would be maybe 100 times than current user plane. So how to automatically deploy the user plane is another challenge. And meanwhile, even for today, for the cloud transformation, from Huawei experience, we believe that the upgrade is a big headache, especially when OpenStack, CloudOS, they upgrade themselves. and it will cost associated upgrade from each VNF. So it's quite time-consuming, and it costs a lot of efforts. I'll give one example here. There's one site. It took more than 600 minutes to just upgrade 50 blades, 50 servers. So it's unacceptable. So we should consider how to make this kind of fine-tuning to avoid this associated upgrade, to make it really decouple each other. The third one is for the expensive O&M, especially for troubleshooting in multi-vendor environment. And from our experience, normally, for some reason, it will take weeks or even months to address the problem. For example, if the user plane performance degraded, we got a lot of this kind of issues, and we should work together to see what's the root cause. Is the cause from the VNF itself, or is the cause from the cloud OS? So I would say it's a very challenging job, and towards 5G, I think the challenge would be more. So for 5G core network, here is our high-level view how to further achieve the success in 5G core network. The first one is for the agility. Definitely, for the 5G, SBA service-based architecture is standardized, and we believe that microservice architecture is the best one for this trend. And also container is a very clear technology trend compared with virtual machine. So how to make the 5G core network more agile is first pillar. The second one is for the acceleration, especially for the user plane. We should consider how to improve the hardware efficiency, maybe use the heterogeneous hardware to accelerate the performance, and also for the computing, edge computing, we should consider like GPU and other kind of stuff to make it happen. The third one, but I think the most important one, is automation. We should consider how to leverage the CI/CD tool chain and how to simplify O&M in the cloud environment. And what's more, how to speed up the 5G services like slicing and mobile computing. Okay, in the following slides, I will elaborate those three aspects one by one. The first one is for the MicroServiceCentric Architecture. If you look at the left side, today we have, in 3BB standard, we have AMF, SMF, so on and so far. But actually, when we realize this network function, we further decouple the functionality into microservices. In this way, you can see the benefit in doing so is that compared with monolithic software, we can maybe, for each week, we can deliver our new release for new functionality. And also, when we do the testing, there's no need to do all the regression tests, maybe 1,000, 3,000 test case. But maybe you can just only test 30 test cases, which only impact our new changes. The third one is for the upgrade. We can just upgrade the microservice itself without impacting others. In this way, it's safer and quicker. So we believe that microservice in 5G core network is mandatory for this kind of business agility. And also, I want to stress here is that, from EPC journey, we already redesigned our architecture. Even for our EPC, for our IMS, it's also service-based architecture. So that's the reason why today, for us, it's very natural and very easy to support 2G, 3G, 4G, 5G SA full convergence. And I think currently we are the only vendor who can support this feature by end of this year. Secondly, for the infrastructure, currently we are based on the virtual machine in the OpenStack, mainly OpenStack based. And we believe that bare metal container would be the target architecture. So here is our recommendation for the evolution. For the new site, especially for the user plane, directly go to bare metal container. Don't use OpenStack or virtual machine anymore. And for the control plane, or for the existing user plane, because we already use the virtual machine OpenStack-based infrastructure. So I think there are two options. The first one is maybe you can use back-to-back, sharing the same hardware resource, but directly deploy the bare metal container for the new capacity. The other one is we still use the virtual machine, the OpenStack, and inside of the virtual machine, we can use the container inside of the virtual machine for the control plane. But anyway, here is our proposal. Huawei can support each options, but we believe that the bare metal container is a target architecture. So for the new site, for the new capacity, we recommend to use bare metal container directly. Okay, so for the acceleration, as I mentioned earlier, for 5G, I think there are two major requirements. The first one is maybe 10 to 100 times throughput, high traffic. The second one is for the edge computing for different use cases, different applications. So from this regard, we are considering how to improve the hardware efficiency. And we all know that for the edge, for the central office, the condition is not so good. It has limited space and power supply. So this, from left side, this is our survey. You can see that maybe 90%, more than 90% central office room, less than 60 square meters. And also, normally the power supply is like less than 5,000 watt. So we should consider how to improve the space and power consumption efficiency. And also, from this, we introduce we call it TCE, this Teleco Cloud Engine for this edge computing and user plane performance. First of all, the performance compared with existing cost server, 2 times, and also for the space, it's 5 times in terms of the density, because we integrated the EOR and the TOR inside of one chassis. In this way, you can just plug and play. So that means you connect the power cable and the network cable, everything's fine. No need to configure the EOR, TOR. It's very complicated, especially for the edge site. The third one is for the power consumption efficiency, more than 40%, and 0 EOR and TOR. This is for the high traffic performance. Meanwhile, for edge computing, we believe that this heterogeneous computing is very necessary. So from this regard, we are using ARM, NPU, GPU, FPGA, and AI for different purpose, for different application needs. So we believe that for the edge computing, for the user plane, this kind of hardware is very necessary to improve the efficiency. The third one actually is for the automation. I think in this forum, there are a lot of speech regarding the automation. Here is Huawei's overview from the cloud network perspective. First of all, we have this, we call it high efficient pipeline for CI/CD, for this DevOps circle. And also, for this CI/CD pipeline, we can fulfill the auto-designing, deployment, auto-testing, and also this auto-upgrade. And meanwhile, based on the AI framework, we can facilitate the cross-layer troubleshooting for the operation and maintenance perspective. So later on, there's one slide to elaborate it. The third one, we call it, actually here is MAE, I would say. It's MBB automation autonomous engine. Based on this MAE, we can fulfill this end-to-end orchestration and pipeline. So based on this pipeline, I think we have 2 intentions. The first one is to simplify the cloud environment integration and maintenance. The second one is for speed up the 5G service creation and service deployment like slicing and MEC. Here, I would say based on MAE, we can fulfill this kind of cross-layer troubleshooting easily and intelligently. Here is one example. Normally, if there's some issue happened, it will cause maybe from the hardware, from the CloudOS, from VNF itself. And unfortunately, today, if there's one issue, there'll be maybe more than 20 or even 50 alarms for this issue. And you have no idea what's going on. And for each issue, if you tackle each issue, that means you will spend a lot of time. Based on this MAE, intelligent based on AI technology, we can fulfill this, we call it correlative analysis. We can understand what's the root cause. For example, here's one example. We can understand, okay, the root cause is from the NFVI, and also we can indicate which server and maybe which CPU has caused trouble. In this way, we can address the problem very quickly, and we can save a lot of OPEX. And also for the 5G, as I mentioned, for COPS and for the MEC, we believe that maybe there's more than 1,000 user plane and MEC deployment. So how to roll out the service quickly? And here is our solution. Before that, we have to configure each UPF and each maybe UR filter and TCP optimization, so on and so far, which the complex O&M is like M multiple L. It's very complicated. But now with our one-stop user plane, we are consolidating because for the edge site, it makes no sense to install different applications one by one. So we use this one-stop user plane concept. We are integrating all of this functionality, and also based on the TCE, we can use the plug-and-play method. That means the control plane, centralized control plane, will dispatch the configuration directly to all of this edge site, even if 100 times or even 1,000 times. It's like we can use only 5 minutes to deploy our user plane. So by this kind of automation mechanism, we can not only deal with the complex O&M issue in cloud environment, but also we can speed up the 5G MEC deployment. Okay, here is the takeaway and recap for my presentation. So we believe that for the whole telco cloud towards 5G evolution, there are 3 key pillars. The first one is for agility from the VNF itself, should be microservice-based, container-based, especially for the environmental container. The second one is for the acceleration, especially for the user plane and for the mobile multi-edge computing solution. The third one is for the automation, based on our MAE solution and the CI/CD pipeline for this cloud environment troubleshooting, and also for 5G new service delivery. Okay, thank you. That's all from my side.